Okay, so welcome back. Now, what we're going to do is we're going to now focus on integrals involving this expression, x squared minus a squared. But before we do that, this is what I want you to try on your own from the previous video on using tangents. So what I want you to do is I want you to evaluate this thing using substitution or rewrite this using tangent theta as a substitution, okay? So again, just work on it. If you get stuck or if you're not sure about it or if you want confirmation, then let me know. But go ahead and just rewrite this using tangent theta. Okay, so now, let's talk about integrals involving this one. Okay, so now in this case here, again, we want to start with the domain. So the domain is going to be slightly different in this case. So the domain of x, right, so this is negative. So this is going to be some constant value of a squared, but it's going to be negative, right? We're subtracting that amount. So where the domain is everywhere where this is going to be greater than or equal to 0, right? So we want x squared minus a squared to be greater than or equal to 0. So again, if we solve for both sides, oops, we get x squared is greater than or equal to a squared. And then what we get is, well, if we take the square root of both sides, well, we get x is greater than or equal to plus or minus the absolute value. But we got to be careful here because there's a plus or minus here. That means that x is greater than or equal to the absolute value of a. So this goes back to properties of square roots. Okay? If we have an even root with an even power, then we have to have the absolute value signs. Okay? So that means x is either greater than or equal to a when a is positive, or x is less than or equal to negative a. Okay? So that gives us a union of two intervals. So this means the domain is going to be from negative infinity to negative a, union a to positive infinity. Okay, so now that's important to know. So that means, again, right, so this is what the conclusion is. Either x has to be greater than or equal to a or less than or equal to a. And so if we divide both sides, right, so if we divide both sides by a, this means that x over a, right? Is going to be greater than or equal to 1. Or less than or equal to negative 1. So this is going to be greater than or equal to 1, because we're just going to divide both sides by a. We're going to divide both sides by a, and so this gives us x over a, oops, is less than or equal to negative 1. Okay? So, now, that gives us something to work with. So, these intervals correspond to the range of secant theta. Right? So, again, we're trying to get a trig substitution. Well, this works with secant theta. On the set of, so secant theta, oops, has the range of what is it? Pi. I think it's 1/2. Oh, hold on. Oh, I'm sorry, I got that backwards. Because this is undefined at 90 degrees. Right? So secant is 1 over cosine, and cosine of 90 degrees doesn't exist. Or, well, no, take that back. It's 0 at cosine. So secant is undefined. So we can't include pi over 2. Okay. So this corresponds to secant on that interval. So it makes sense to use the substitution secant theta equal to x over a, because we know there's going to be a correspondence here. So that leads us to our substitution. Okay, so now, how do we use that? Well, we're going to use it the same way that we've done the last two. Okay, so what we're going to do is we're going to use secant right, so x over a, or A secant theta. And this is going to be for the interval from 0 to pi over 2. Right? Or pi over 2 to pi. And then our derivative, dx, is going to be a secant theta tangent theta d theta. And then our corresponding triangle right? So here's our theta. And so remember, secant is 1 over cosine, right? So for theta, well, cosine is opposite over adjacent, so this is going to be adjacent over opposite. So cosine is adjacent over, excuse me, not adjacent over, adjacent over hypotenuse, so this is going to be hypotenuse over adjacent, so this is going to be x over a, and then of course, now here, it should make sense, right? Because a squared plus this squared equals this squared, and of course, you can subtract, right? Subtract a squared from x squared to get b squared. So this is going to be our x squared minus a squared. Okay, so that makes sense. So this is going to be our reference triangle that we're going to use as well to make sure we put it back in terms of x. Okay, so in the next video, I'll show you the steps and we'll do some examples.